Okay, so what is diffraction? Well, if we consider a wave moving along like this, and each of these lines here is a wave front, so these are the peaks of the wave. Imagine looking down on the sea. Distance between each peak is the wavelength. So it's moving along like this, and it moves through a gap. And there's the gap. And what we notice is something pretty amazing happens. It gets through the gap, rather than just travelling kind of a straight line like that, it spreads out like this. And it's this spreading out that's called diffraction. Now, that's the process known as diffraction. Now, it doesn't only have to happen to a gap as well. It can happen when it goes around a corner. We get a similar thing as well, but it doesn't happen quite as much at the top then. But it does bend around this here. It's the reason why we can hear radio waves over hills. Radio waves can pass over hills and around buildings. It's the reason why sound waves travel around corners so well, like this. Now, if we have a gap, that's the best time for this to happen, the most bending we notice is when the gap size is similar to the wavelength. So that gap size was very similar to the wavelength, so we got a lot of diffraction happening. If the gap is too small, like this, then it can't get through, and it reflects off. So it just hits this, and then starts to go back like that. Now, an example of this, a nice analogy that I like to use here, is imagine a crowd of people. If you imagine a crowd of people and you ask them, if you ask them to line up single file and walk through a door, then what you notice on the other side of the door, as soon as they go through, people generally spread out. They tend to move. So the people, and we do behave like waves, the people spread out like that. So if they're coming this way, as they go through the door, they spread out. If the door were too narrow, the people couldn't get through. If the gap were very, very big, so if we had these people here and we had a huge gap, much, much bigger than the people themselves, they almost don't even know they're going through a gap. So what happens is they continue to move as they were. People only spread out when they go through doors. It's really peculiar. They don't know they're actually passing through a gap here, which means they don't spread out as much. Okay, so that's diffraction.